Okay, let's have a look at example number 2 here. Now what we have in this case is we have a current source. Now this current source here is a current dependent current source. So the actual value of this source is 0.9 times the current IX. Now the current IX is the current that's actually going through this 5 ohm resistor. So the issue is, well, how do we really approach this problem? Well, again, we could actually use a nodal analysis method here, or we could define this as our reference node. All right, now reference node is set to 0 volts. And look, you could say, well, the only other node we've got is really this one over here, and I'm going to call that guy V1. So that's the V1 node, which is all of this over here. So once again, let's start summing currents, okay? So what do we have coming into the V1 node? So let's write that down, V1 node. Okay, we've got 4 milliamp, or 4 amps, I should say, coming into that. So we'll write that down. We've got this current here, IX, and so that is what? That is a minus IX. Okay, we've got this current in the 2 ohm resistor, and again defined in this direction, so it's a minus V1 over 2. We've got this current from our dependent current generator here, which is a plus, isn't it? That's a 0.9 times IX. We've got this current over here, and this current, of course, is a minus V1 over 10. And look, I forgot to label this guy here. That's actually a 2 amp source. It's coming out, and so that's a minus 2, and all of that is equal to 0. All right, so in this particular problem, we have V1 as the unknown, and we also have an IX as the unknown. Well, look, IX, can I write that in terms of V1? Well, yeah, I can, can't I? And I can say that, look, that current IX, defined in that direction, is simply going to be equal to V1 divided by that 5 ohms, okay? Then I can put this really into the above equation. I only got one unknown at that point. So let's go ahead and do that. So what do we have? We have basically 4 minus IX, which is a V1 over 5. I have a minus V1 over 2. I have the plus 0.9 IX. Well, remember IX is that V1 over 5, minus the V1 over 10, and then the minus 2, and all of that is equal to 0. All right, collecting my terms together, what do I have? I have 4 minus 2, which gives me a 2. And let me take all the V1 terms to the other side. So that's equal to, this going to the other side, that's what? That's V1 over 5. So that's a, what is that? That's a 0.2 V1, okay? This guy over here would be what? A plus, that's going to be a 0.5 V1. Then I've got this guy over here, which is what? That is my basically 0.9 divided by 5 over to the other side. That becomes a minus, doesn't it? And that's going to be a 0.18 V1. This to the other side is a plus, isn't it? That is going to be a plus 0.1, and that is V1, okay? So all we need to do basically is add up all our V1s, and if we do this, we have 2 is equal to 0.62 times V1, and so therefore I can say that V1 is really equal to what? It's equal to 2 divided by 0.62, giving me a V1 of 3.225 volts. Okay, so that's a second example. In this case, we're using what? We've got a dependent source, which is a current dependent current source. Okay, so that's example number 2.